believe that we're live. And we got audio, perfect. Let's go ahead and share out that we're live on the tweets and on the Slack and then everything else, and then we can begin. All right, perfect. Okay, so let's go ahead and get up our chat set up here. Okay, so we got that. You can be left aligned here. And what else do we need? YouTube open. All right, so we're continuing on with our GitHub location, which is using iterator trait methods instead of indexing. And I think what we were doing was we were improving the chapter 12 project, that the command line grep project. Let's go check that out. So cd document running chapter 12. Oh, I couldn't figure it out. Any grep. And we'll open up code here. So what I remember last time, I actually played around this idea thing with an editor for Rust, but it wasn't ready yet. So maybe when it's out of like alpha beta stage, look at JetBrains IDE for Rust. But until then, let's take a look at what we got here. So I think we changed main so that we could hand it the env args, and it's gonna handle this directly too. But if we're gonna hand it the env args directly, then we also need to do the exact same thing to this test here, which is input is a vector of this. So now I'm not exactly sure what we're going to input to this to make it look exactly like that. Seems a bit interesting. Well, we may have to abandon these tests until we learn exactly what the args look like, and then deal with that. I think the args are just a string. But I could be wrong. We can come back and make these work after we get the rest of the stuff working. So using this, let's make chat dark mode and hit refresh on it just to make sure that everything is working just fine. Okay, so using iterator trait methods instead of indexing. Miguel, hello. I'm glad I refreshed right before your message came in as opposed to right after. Good morning. Welcome to the new week. Next, we'll fix the body of config new. The standard library documentation also mentions that standard environment args implements the iterator trait, so we know we can call the next method on it. Listing 1327 updates the code from listing 1223 to use the next method. So public function new, it takes in standard args, which is standard environment args. It's going to return the exact same thing. We then call args.next because we don't care about that first one, which is just the location of where the binary is. Let query equals match args.next, and then file name is match args.next. Interesting. Okay. So let's try that. Inside of our library, we have config, new function, and it is taking input and case sensitive. Case sensitive can still come in here, and we didn't change that, right? No, we didn't. This is going to take args type standard env args. I kind of like the idea of bringing this in as a use statement. Use standard env args. It's the type. Oh, is that not it? Args, the capital A. Okay, I also realize that this is covering the screen. Don't want to do that. Okay, so if we have type here is args, case sensitive is just fine. The first thing we want to do is just ignore that first next. So args.next, just like that to ignore it. The first one that comes in is going to be the file, no, the search, the query. So that query equals match on args that args.next. So next is going to return what it is. And so either we're going to have, it's going to be a sum or num, right? So sum is going to be query, and then we're just return the query. However, if it's none, at this point in time, we can now have this error. Let query is match if input is length. I guess this is what's going to be returned. So I think we'd want to just return error, and it's going to be not. We should probably keep this exact message right now. Well, no. The best thing to do would be, now that we know exactly what the problem is, well, do we? And this one is, we don't have a query. So query statement, query option. Okay, so that's let query, and then we're going to want to do the exact same thing with let file name. So let file name equals match args.next. We're going to get sum and the file name. I'm going to return that. Otherwise, we're going to get none. And we're going to return, literally return error. So instead of query options missing, it's file option missing. And so once we have this, then we can now create this config. So well, it's just create a new one. We might as well just get rid of all of this. That is not what I want to get rid of. Just you. Okay, so now that we have these things, return OK, config, and we need the query, file name, and case sensitive. And that should be fine returning this. Mismatch types, expected struct, standard string string, found reference, so we need to string from this. Okay, so that should work for that. Okay, expected one of, or an operator found okay. It's because you need to be semicoloned. You also need to be a string. I mean, I could see why they decided to do like the static strings in here. Okay. Cannot borrow immutable argument args as mutable. Interesting. Okay, so we need to bring this as mute args like that. Okay. That seems to work. Remember that the first value in the return value of env args is the name of the program. We want to ignore that and get to the next value. So we call next and do nothing with the return value. Second, we call next to get the value we want to put in the query field of config. If next returns a sum, we use a match to extract the value. If it returns none, it means not enough arguments were given and we return early with an error value. We do the same thing for the file name menu. Did I actually delete the other stuff? I did. Making code clearer with iterator adapters. We can also take advantage of iterators in a search function in our IO project, which is reproduced here in listing. Well, okay, so it sounds like this should still work, right? So if we cargo run and we hand it like hello and the test text. Right, okay, so that's still working, which means that we need to now run our test to fix those. So cargo test. So in test minigrep rs, expected struct standard env args, founded struct standard vec vect. So that is a problem now. We need to figure out what does args need? Because in here, we're now passing into config new a vector where previously we had args. Can we do like args new? I don't think that's a thing. Like standard fs. It's standard env. Oh, there's just an item. Type item equals string. If I do something like there's nothing for us to use there. I think unfortunately we may end up using. Well, okay, so we need to recreate what the args are. When in doubt, pull up the docs and see what it's returning to. Yeah, that's definitely true. Let's do that. Rust lang or rustling standard env args. Public function args returns the argument which this program was started with, normally passed via the command line. The first element is traditionally the path of executable. So it returns type args. Okay, that's not super helpful. Public struct args, fields omitted. I need those fields so I can create new ones. An iterator over the arguments of a process, yielding a string value for each argument. Is there a way for me to see what this struct is? Because the fields omitted. Public struct args. I know that there is somewhere that like showed these. Isn't like current directory, current exe. Well, it's also a structure, but it has an unknown hit source. Ooh, okay, so that's public struct args OS. Okay, args. Inner args OS. An iterator over the arguments of a process yielding an OS string. Okay, an iterator over the argument of a process yielding a string value for each argument. This struct is created by the standard env args function. See its documentation for more. Struct is created. Okay, so standard env args function can also create it. The first element is traditionally the path of the executable, but it can be set to arbitrary text and may not even exist. This means this property should not be relied upon for security purposes. Okay, so standard env args lowercase. Function args returns args. Doesn't look like it's taking anything in. Returns the arguments with or which this program was started with, normally passed via the command line. The first element is traditionally that, blah, blah, blah. This means this property should not be relied upon. Returned iterator will panic during iteration if any argument to the process is not valid Unicode. Examples: use standard env for argument in env args. That's not really helpful. Looks like it's just a value of strings that's using the custom iterator over. Yeah, that's what I'm thinking. I wonder if I could do the same thing. I create a struct in the test that allows me to it has a next method on it that just gets the next one, and then we go on. I think that might be what we have to do to get this working. So, because args didn't take anything in, so we can't really create it that way. And can it be? I don't think it can be like overridden in that way. All right. So what do I want to do? I want to Rust lang add iterator or add next to string. Oh, I remember. It's in this chapter, isn't it? Because we just did it not very long ago. Trait iterator. All iterators implement a trait named iterator that is defined in the standard library. The definition of the trait looks like this. Recruiting our own iterators with the iterator trait. Okay, so implement iterator for counter. And then we'll add the next thing to it. So I guess this means I need to create my own type. Basically, I want to create a structure that allows us to, instead of just doing this vector as input, or maybe the vector is fine, but we need to have some kind of next with it. Or it's taking in type args. So that won't work either because I can't convert it. So I would probably need to change the way I was doing things. I think for right now I'm gonna have to leave this go until I think about other ways to deal with it. Specifically, the way the book wants me to do it is putting that logic inside of config to go and get that, which is interesting. But the other problem is it is that's making it not work the way I want it to anymore. Right here, because if we're taking args with just type arguments, standard env args, so I need to create this to pass it in. Otherwise, it won't work at all. Even if I create just a string that has an iterator on it, it won't work because it won't. I would need to make a generic just to test it, and I don't think that's a good idea either. And is there a way? Let's see. Rust test passing in arguments. Is there a way to test that? Cargo test with arguments can execute only one test. Is that still true? Oh, right. Test is for filtering out what test run. That link under the first search, good. Passing arguments through cargo. I have some sample code that is currently making use of get ops, which is specified as a dependency in cargo.toml. Pass argument -- test. No, the sub search under that. Oh, one of these. Creating a standard env args iterator for testing. Okay, nice. Is there a way in Rust to create this from a vec string in order to use it in a test function? Okay, so that's okay. The fields of standard env args are not documented, and there doesn't appear to be a function, public function to create one with custom fields. So you're out of luck there. But since it's just an iterator over the arguments of a process, yielding a string value for each argument, your functions can take a string iterator or vec without any loss of functionality or type safety. Since it's just a list of strings, it doesn't make much sense to arbitrarily limit your functions to strings which happen to come from the command line. Looking through Rust's own tests, that's just what they do. There's a lot of let args vec string equals env args collect. Oh, interesting. Okay, so they're basically saying it's not possible. That's sad. So what we're looking at here is not being able to bring in mutable args, but being able to bring in like a vector and convert it. So you don't bring in standard args and just make a fake call. It's not that bad. Yeah, so I think we go back to this being a vector, right? Or this taking in an iterator. Because what they're suggesting here is build new config. Config is really parse args. Oh, interesting. Okay, so this is, so it's just a vector. The config is this. Okay, perfect. So args has a next on it. So, but we need to convert it into a vector of these strings first inside of main. So the best way to do that is we have these env args. We need to still do that and then collect them into a vector, just like we did before. So that was, oh, it doesn't remember it. Okay. Let args equals env args dot, can we do collect? Yeah. And then we want to pass in args, because I believe that vectors have that, right? Huh. You're not yelling at me for type error. That's not really what the Stack Overflow was suggesting. It was just saying make a fake vector in the test. But if I make a fake vector, that function takes in type args. And right here, function main, let args, so they're turning this into a vector and then passing it into config parse. And I think that so that they can then pass in a vector into test, because the function can't do that. They're saying you don't really need to test args since it's part of the standard library, so you don't need to lose safety over not testing it. Okay, then how do I not test it? I guess I don't test it. Just make a vec in the test called args. All right, let's undo this, bring it back to what I just had. env args. In the test, we have a vector args right here, which is sort of replicating that, and then we're passing that into config as args. But it's mismatched types. Expected struct standard env args, found struct standard vec vec. Then coming back here, implement config. Well, okay, so we go to run. Oh no, we're not doing run yet. We're doing config. So we do the config. We can't pass this in, so we can't call new on this. We're gonna have to make a generic for new that takes in either args like this or vector. And I think that's what the crux of the problem that we really have is that we can't call this function. And I guess I could just create a config object myself. Yeah, I forgot the new part that's causing the issue. Yeah, that's my problem. But because these are public, I could bypass new and just not test it. But instead, we'll test would reference open and close square brackets work. Where would I put that? The reference brackets. Well, that seems like it would be setting up where to be like a reference that I'm passing in or slices that I'm passing in. But that's not what I want either. I want to bring in like the full type here. But I think what I could do is I could just say, hey, you know what? I don't care about, we're just not going to test config. Instead, we're going to test run. So we'll just bring out config here. So public struct config. So we have mini grep config. So here, case sensitive search. Wait, mini grep, this one. So here's our vectors, hello test. What we probably really want to do is say let config equals grep config, and then inside of here we're going to have a variety of strings. So string from hello. Oh, what is this? This is the query. And the other one is the file name. And it's also a string from test text.txt. Okay, so we create the config. We don't need these arguments anymore. That case sensitive search equals false. The config grep config new args in this case is going to be we don't need a new, and then we just run text equals grep run config. We unwrap that and then we start equal. So try this. Missing field case sensitive. Oh yes, case sensitive search. What is it? Case just underscore sensitive. And let's say insensitive, so false. Okay, so I think that works there. We have to fix it here as well. So input, we don't need this. We don't need case sensitive. We're replacing config. So do the same thing here. That config equals grep config. And the first thing is going to be the query. And we're going to do string from hello. That. Then we have the file name. String from file name. And then we have the case sensitive. And this is going to be true. And then you, we don't need you anymore. We don't need you anymore, or you. Okay, so that should work. So we're going to bypass the new function and just go straight into there. Unused variable, case sensitive search, right? I don't need you. All right, so let's see how you're running. Cargo test. Okay, so mismatch types. Source lib 87. Okay, so another test, of course. So parse standard in. So this is testing whether the new function, we can't just do this anymore. So we have to get rid of this test completely. So we'll run this again. And we have one more, which is now on 86. And this is the exact same problem, which is what the error messages are, and we can't test this the way we've written it. So in reality, I don't actually think that it's the best practice to pass the arguments directly in here and use that. It probably would be best to create my own, if I want to use iterators for it, to pass those in directly. Or create some kind of like struct and do that separately. It just now means that we don't have as many tests available for us. But the few tests that we do have do work. So if we do cargo run, it's still working. So there is that. Blah, late reply because Firefox keeps freezing, but to clarify, I meant that as a possible solution, an alternative to args in order to make the fn-new more generic. What you're doing now makes more sense. Yeah, no, I agree that not using args would be the best in a production application. I think they're just showing us what we can do, and because it's not fully, the new function doesn't seem to be tested at all, which is why it seems to work. Unless of course they wrote tests for it after the fact, but I can't remember if we did or did not. But all right, where were we? Making code clearer with iterator adapters. We can also take advantage of iterators in the search function in our IO project, which is reproduced here in listing 1328 as it was in listing 1219. So public function search, we take in the query, which is a reference to string, and we're going to return a vector that mute results equals vec_new for line and content set lines. We can write this code in a more concise way using iterator adapter methods. Doing so also lets us avoid having a mutable intermediate results vector. The functional programming style refers to minimize the amount of mutable state to make code clearer. Removing the mutable state might enable a feature enhancement to make searching happen in parallel, because we wouldn't have to manage concurrent access to the results vector. Listing 1329 shows this change. It's a filter. So we're going to run the filter, we're going to take in the line, and then we're going to do lines contains query. And if it does, then we keep that. So actually I agree. I think that's pretty awesome. Let's go into search and we can change that. And this one, we shouldn't need to change the test at all. It should just work. It should just work just fine. So run search case insensitive, search case sensitive. We should probably be able to, let's see, query to lowercase. Query is a string. Let mute results. So we don't want to have a result. We want to then return directly off of this. For line and content.lines. And I think the way they're doing this, content.lines. Okay, so instead of our for result, instead of this, we're still just going to take if line to lowercase. Let's do this right out here. So we're going to say content.lines, which is a function. Then we can do .filter, and we're going to take in a closure here. This is going to be the content. So we could say line. And what do we want to do? We want to check something for truth value. So basically, line.to lowercase. So line.to lowercase. If that contains reference to the query. Okay, so this will return exactly what we wanted to, and we can get rid of you. Mismatch types expected struct standard vec found struct iterator filter. Right, because then they collect it at the end. So we can do what they did, put these on two different lines, and then dot collect like that, which will collect this into a vector, which then returns it out. All right, perfect. Then we can do the exact same thing to search case sensitive, except it's a little bit easier. We don't need a result at all. In fact, we're just gonna contains query. So line contains query. This all goes away. And it's going to be, okay, content.lines filter. This takes in line and line.contains query, like that. Collect. Here we go. Let's check to see if this still works. Cargo test. Everything's still good. Recall that the purpose of the search function is to return all lines and content that contain the query. Similar to the filter example in listing 1319, this code uses the filter adapter to keep only the lines that line contains query returns true for. We then collect the matching lines into another vector with collect, much simpler. Feel free to make the same change to use iterator methods in the search case insensitive function as well. The next logical question is which style should you use in your own code and why? the original implementation listing 1328, or the version using iterators in listing 1329. Most Rust programmers prefer to use the iterator style. It's a bit tougher to get the hang of at first, but once you get a feel for the various iterator adapters and what they do, iterators can be easier to understand. Instead of fiddling with the various bits of looping and building new vectors, the code focuses on the high-level objective of the loop. This abstracts away some of the commonplace code so it's easier to see the concepts that are unique to this code, such as the filtering conditions each element in the iterator must pass. But are the two implementations truly equivalent? The intuitive assumption might be that the more low-level loop will be faster. Let's talk about performance. All right, moving on. To determine, or comparing performance, loops versus iterators. To determine whether to use loops or iterators, you need to know which version of our search function is faster, the version with an explicit for loop or the version with iterators. I'm curious why content lines don't need to be in a function. Does it just hold all the results in memory, then just do one gigantic implicit return? Hold on, let's go take a look at that. The content lines, like this. Content.lines. Oh, you mean the filter? So it's not. So this is a higher order function, which also means that it's not going to be mutating the content at all. It's creating a new. This is creating a new iterator essentially. Content.lines. I don't think it's creating a new one off of content. And if this is similar to other languages, what would be really awesome to like find out for real to make sure I'm correct with this. Whatever this is returning is going as the input to filter, and that's how the dot things are working. So it's not just waiting until the very end. It's like it's returning directly into filter right then, which is then passing ownership into filter too for the iterator, because the iterator is something to be owned. I think that's what you're talking about, right? I guess we could also do the print :p to look at the locations in memory. To determine whether to use loops or iterators, you need to know which version of our search function is faster, the version with an explicit for loop or the version with iterators. We ran a benchmark by loading the entire contents of The Adventures of Sherlock Holmes by Sir Arthur Conan Doyle into a string and looking for the word "the" in the contents. Here are the results of the benchmark on the version of search using the for loop and the version using iterators. This nanoseconds? The iterator version was slightly faster. We won't explain the benchmark code here because the point is not to prove that the two versions are equivalent, but to get a general sense of how these two implementations compare performance-wise. For a more comprehensive benchmark, you should check using various texts of various sizes as the contents, different words and words of different lengths as the query, and all kinds of other variations. The point is this: iterators, although a high-level abstraction, get compiled down to roughly the same code as if you'd written the lower-level code yourself. Iterators are one of Rust's zero-cost abstractions, by which we mean using the abstraction imposes no additional runtime overhead. This is analogous to how Bjarne Stroustrup, I cannot pronounce that, the original designer and implementer of C++, defines zero overhead in foundations of C. We losing frames again? Yeah, drop frames, 157. Getting close to 8 o'clock too. It doesn't look like it's going up right now. It just a little blip. So let's hope that it doesn't continue for the next 9 minutes. In general, C++ implementations obey the zero overhead principle. What you don't use, you don't pay for. And further, what you do use, you couldn't hand code any better. As another example, the following code is taken from an audio decoder. The decoding algorithm uses the linear prediction mathematical operation to estimate future values based on a linear function of the previous samples. This code uses an iterator to chain to do some math on 3 variables in scope: a buffer, slice of data, an array of 12 coefficients, and an amount by which to shift data in QLP shift. We've declared the variables within this example, but not given them any values. Although this code doesn't have much meaning outside of its context, it's still a concise, real-world example of how Rust translates high-level ideas to low-level code. Okay, so let buffer mute I30. So a buffer is going to be I32. We don't know how big it is. Let coefficients is I64, 12 of them. Let QLP shift is I16. For I in 12, starting from 12 to buffer.length, let prediction equals coefficients.iter. Zip it, map it, and then sum all those things up. Let delta equals the buffer prediction as I32 plus the delta plus the change. To calculate the value of prediction, this code iterates through each of the 12 values and coefficients and uses the zip method to pair the coefficient values with the previous 12 values in buffer. Then for each pair, we multiply the values together, sum all the results, and shift the bits in the sum QLP shift bits to the right. Calculations in applications like audio decoders often prioritize performance most highly. Here, we're creating an iterator using 2 adapters and then consuming the value. What assembly code would this Rust code compile to? Well, as of this writing, it compiles down to the same assembly you'd write by hand. There's no loop at all corresponding to the iteration over the values and coefficients. Rust knows that there are 12 iterations, so it unrolls the loop. Unrolling is an optimization that removes the overhead of the loop controlling code and instead generates repetitive code for each iteration of the loop. All of the coefficients get stored in registers, which means accessing the values is very fast. There are no bounds checks on the array access at runtime. All these optimizations that Rust is able to apply make the resulting code extremely efficient. Now that you know this, you can use iterators and closures without fear. They make code seem like it's higher level, but doesn't impose a runtime performance penalty for doing so. And that's one of the things that we see like with JavaScript, with Node.js, Python, with a lot of other languages, which is just write the language in the most readable way you can. The compiler teams are actually analyzing how people are writing code and optimizing, like they do a pre-optimization often for the code that's standardly written. I think the best example was for a while, it was faster to do reverse loops through arrays in JavaScript, mainly because that's just some crazy thing about what was happening with conversion to binary from JavaScript using the C++ engine in Chrome. But then the Chrome team fixed the problem, and suddenly now it rewrites it much faster on the fly if you're going forward through the loop. So everybody, it sort of screwed everybody up. But these are micro optimizations. Unless we're working with like huge data sets or really need every microsecond, we're probably not going to need to worry about that. Summary. Closures and iterators are Rust's features inspired by functional programming language ideas. They contribute to Rust's capability to clearly express high-level ideas at low-level performance. The implementations of closures and iterators are such that runtime performance is not affected. This is part of Rust's goal to strive to provide zero-cost abstractions. Now that we've improved the expressiveness of our I/O project, let's look at some more features of Cargo that will help us share the project with the world. All right, so what this means is that we are finished with chapter 13. So let's go ahead and update where we're going to be at next time, which is chapter 14, more about Cargo and Crates.io. So go ahead and close you. And open you here so I can update where we're at. Okay, so in our README, currently at more about Cargo and Crates.io, and then we also need update the URL. Okay, perfect for you. Is there anything else that we need to care about for this? I don't think so off the top of my head. Let's go ahead and push up. Update finished. You could just say finished chapter 13. And for you to updated mini grep to use iterators from chapter, and we'll send that on up. Where's our stuff? I guess we don't have it anymore. We'll come on over here. I have all the code for everything we just did up on GitHub here. I have links to that in the stream description, but also the video description in YouTube. Thank you everybody for stopping by and taking a look. We've been doing this every single weekday morning at 7 a.m. Mountain Time, and I have no plan to not do that again tomorrow. Fun double negative there. Basically, we're going to be continuing on tomorrow morning at 7 a.m. Mountain Time. We'll be starting chapter 14. I don't really have anything else, so follow me in all the places if you want to get notifications, or you can follow me on Twitter and hope that then hopefully I'll remember to tweet out when I'm going live, or if I'm doing some kind of other alternate stream. But with that, I'm gonna go get ready for my day. Luckily, we didn't have very many drop frames today, so everything was good, and hopefully that will stop soon, and we'll get back to smooth streams whenever we want. All right. Once again, I hope that you all have a great rest of your day, and I'll see you tomorrow.